Welcome back to the deep dive. Today, we are taking a massive leap into a world where high-end computer-aided design meets, well, centuries of traditional jewelry craftsmanship.
We are.
We're diving deep into algo jewels,
Right.
where AJ is a system designed to, completely transform how jewelers go from concept to a final production-ready design.
And this is such a crucial deep dive for you because AJ isn't just about drawing. It's really about writing the instructions for a piece of jewelry.
Like a recipe.
Exactly. Like a master artisan follows a precise set of steps. So our mission here is to unpack the core thinking behind AJ, understand this huge shift it makes toward algorithmic design, and, well, explore the whole digital workbench it offers.
So this is basically a shortcut for you to understand why experts like graduate gemologist Ralph Schroeder built this system for jewelers, by jewelers.
That's the key.
Okay, let's unpack that core idea right away, because this seems to be where the whole promise of efficiency lies. The sources all emphasize that AJ is the future of jewelry CAD because it moves beyond what they call static modeling.
Right, static modeling, that's the old way. You draw a shape, and if you need to change, say, the ring size or the stone dimensions,
You have to redraw everything.
you have to redraw and rebuild every single attached component. The claws, the bezel, the shank, all of it. AJ pivots to parametric design, which is sometimes called associative modeling.
So can you walk us through a quick example of that? Like how that hierarchy works? Where does the constraint start, and what's the real benefit?
Okay, so the constraint starts with a foundational input. Usually that's the ring size or the exact dimensions of your main gemstone,
The most important variable.
the most important one. And in an AJ design, every other element is mathematically linked to that foundation. So if you have a complex pave band and your client needs to go from a size 7 to an 8, you just change the input slider.
From 78. And then,
And then the shanks thicken just the right amount. The little melee stones all shift their positions to maintain perfect spacing. The pongs adjust their height. It all happens automatically,
yeah.
simultaneously.
That's the difference between, what, minutes of adjustment versus potentially hours or even days of meticulous redrawing.
On custom pieces, absolutely. It's a huge efficiency gain.
Incredible.
And that speed and control, it brings us right to the algorithmic foundation of the whole thing. Every single component in AJ, every definition starts from one place. The origin point, 0, 0, 0, 0.
The source is called as the Big Bang of the design universe inside Rhino and Grasshopper.
It's a great analogy. It's a really structured approach, rooted in geometry, and it's known as the chain of design.
Okay.
Think of it like this. Your design moves out from that center point in a logical sequence. A ring starts at 0, 0, 0 that defines the center axis, which defines the radius, which then defines the size circle, and so on.
So everything builds on the thing that came before it.
Exactly, for its own strength and coherence.
So how are we? How are we communicating these instructions? We're running this inside Rhino, the CAD program, but the actual algorithm work is happening in Grasshopper or GH.
Right, and an algorithm is really just a recipe. That's a perfect way to think about it.
Okay.
It's a precise, written procedure to solve a problem. You know, jewelers already have these recipes, a standard process for making a setting or assembling a head. Grasshopper just digitizes that process.
So instead of physical tools, you're using digital components and linking them with little wires on the screen.
You're linking them with wires in a visual script to create that exact set of instructions.
Now, this is where it gets really interesting for me because we're talking about incredible precision. The source material says Rhino and Grasshopper operate at a tolerance of up to 0.001 millimeters.
It's an extreme level of precision. To put that in perspective for you, the acceptable tolerance for a finished piece of fine jewelry is maybe 0.1 millimeters.
Wow.
So yeah, AJ is operating at 100 times that level of precision, and that means your inputs have to be perfect for the geometry to calculate correctly.
And this leads to that fascinating idea of shaking the inputs. Can you explain what that means? Why do you need to do that?
Well, because the computational engine is always searching for a mathematically complete, closed solution, something solid and printable. If your input parameter, say the radius of a curve, is off by just a tiny, tiny amount,
Like an amount you can't even see.
an infinitesimal amount, the engine might not find a clear path to the solution, the shape just won't generate, or you'll get an error.
So you have to nudge it.
You have to nudge it. Precisely. Shaking the inputs just means making a tiny adjustment to a slider, moving a number by a fraction of a thousandth of a millimeter to force Grasshopper to find the next valid computational point.
And that subtle movement is often the difference between seeing a beautiful form and nothing.
Or a broken calculation. Yeah. It's an act of digital refinement that's just required by how precise the system is.
It sounds like a system that demands more than just design talent. You need a foundational understanding of the structure you're building.
Oh, absolutely. To use AJ well, you need more than just CAD literacy. You need a background in traditional jewelry making. You need to understand hand setting, finishing, casting, metal tolerances.
So that practical knowledge informs how you use the digital rule.
Exactly. And on the digital side, yes, the system does rely on math and geometry concepts. Things like sets, vectors, lists, and domains.
Wait, I don't want you to feel overwhelmed by math jargon here. If I'm an artisan, what should I think of when I hear vector in the context of setting a stone in AJ?
That's a great question. Forget the academic definition. In AJ, a vector isn't some scary math concept. It's just the precise angle and direction you need to rotate a diamond.
Ah, okay.
It ensures that every prong is sitting perfectly perpendicular to the metal surface. It's critical for security and for light reflection. You're structuring your traditional knowledge using these mathematical rules.
That makes perfect sense. Okay, let's move on to the actual digital workbench, the toolkit itself. Since everything radiates from that central point, I assume the foundation has to be defining curves and profiles.
Correct. The core of the system is the AlgoJoule Scurv stab. Curves are foundational because all 3D surfaces and solids, they all start as 2D curves.
Right, and for almost any ring design, the most important starting point has to be the ring sizer 1.1 component.
That is the anchor component. It's the critical first step in every single definition because it instantly generates all the guides you need. The base diameter, the cylinder, the offset thickness guides. It handles international sizing, C&D USA, Euro, and everything you build after that refers back to the radius it defines.
Okay, so once that core ring geometry is set, you need to define the shape of the metal. I saw the Universal Profile Maker 1.2. That sounds essential for any custom work.
It's the bridge. It's the bridge between traditional craft and the algorithm. This component lets a designer draw any custom curve, maybe a profile they've sketched for a unique band, and just instantly set it as the profile for a sweep.
So you can bring your own unique visual style into this parametric workflow.
Exactly. And the system even encourages inspiration, with components like Kaleidoscope 2D 3D 1.0, which deforms a curve in space so you can explore different design ideas. It lets the math generate ideas you might not have sketched yourself.
That's very cool.
And that creative energy carries right over into the AlgoJoule's Gemstone tab. Obviously, the engine needs perfect stone meshes to work with. That's where Gemesh Cutters 1.1 comes in.
And that tool provides a full selection of meshes, round, cushion, heart, and heart haze. And they take length, width, and depth in millimeters. What's the key utility there for setting prep?
It's a little slider called offset girdled from stone.
Okay.
See, when you create a bezel, you can't have the metal right up against the stone. You need a precise gap for fitment, for finishing. This slider instantly creates that necessary offset curve at the girdle. It's a small detail, but it saves so much time.
And I imagine for huge projects, there are tools like Pavetta Surface with Microcutters 1.2.
Yeah, that one is designed specifically for placing hundreds of stones densely onto really complex curving surfaces.
Okay, so you've got the stones. You need the hardware. The system provides these pre-made complex algorithmic clusters in the AlgoJoule settings tab, things like Halo Setting 1 and Cluster Head 1.0.
And for the connectors and closures, the AlgoJoule's Findings tab has functional elements like a box clasp 1.0 or even decorative things like a Celtic knot 1.0. You're basically assembling complex systems using pre-tested recipes.
Let's move to the most visually compelling part, shaping the metal and seeing that associative magic in the AlgoJoule's Shanks tab.
Let's use two great examples here. First, the Ebb Flow Band 1.0. This generates a really sophisticated organic wetting band based on a sine wave.
A mathematical wave.
Yeah, it's actually made of two interlocking bands, but instead of redrawing both curves by hand, the designer just uses one slider to adjust the number of waves and how high they are. Both bands recalculate and keep their perfect fit automatically.
So you're saying I don't draw the shank. I just define the mathematical relationship that controls its flow. That is a massive conceptual leap.
It really is. And now consider the Mobius ring 1.0. A Mobius strip is a mathematically complex form that represents infinity. Making that size adjustable is normally a nightmare.
I can imagine.
But because it's tied all the way back to that first ring sizer component, the entire complicated twist and form, it all remains perfectly scaled and sized for production.
And what if the client wants texture? I saw the hammered wedding band shank 1.0.
Yep. You can take that smooth band and with a few clicks, add a deep hammered texture or even a geometric Voronoi cutout pattern across the surface. You're manipulating the math to generate the finish, not mapping a texture manually.
Once the design is mathematically complete, the focus then shifts to presentation. The AlgoJewels Render tab seems essential for this,
It is. It has the staging tools you need for the final client viewing.
like placing a bangle design onto a mesh of an arm or using the Rinbox maker to simulate a presentation box. That kind of visualization is key for getting client sign-off.
Absolutely. And the integrated display tools like Metal Color Display 1.0 and Gemstone Color 1.0 let you customize reflection, glossiness, and transparency. That's critical because clients need to see exactly how light will play with the finished piece.
And connecting this to the bigger picture, the usefulness of AJ doesn't stop at the pretty picture. It goes right into the manufacturing process.
It does. The AlgoJewels printing tab has components like Casting Gate 2.0 and Small Support Generator, which directly address the needs of 3D printing and preparing the wax for casting.
But what seems truly unique to me, and a huge value add for a professional jeweler, is the dedicated business intelligence, the AlgoJewels Zilliance tab. This isn't just a design tool, it's an integrated financial estimator.
This is a huge competitive advantage.
So how does it handle cost estimation so well?
Well, it tackles it from three crucial angles. First, the Gold Weight Estimator 1.0 calculates the rough casting cost. But crucially, the sources specify that it adjusts the daily market price with a mandatory $125 per ounce buyer's premium.
Wait, they build the casting house markup directly into the tool.
They do.
So it accounts for that real-world friction of manufacturing, which is usually a manual calculation a jeweler has to remember.
Exactly. They're anticipating the operational costs. Second, they integrate live market data. The Kitco Gold Price Finder 1.0 pulls current metal prices in US or Canadian dollars.
So the calculation is based on real-time volatility, not old numbers.
Right. And finally, the ultimate goal, pricing. The Retail Price Estimator 1.0 uses all those inputs to calculate the final retail cost. So the jeweler can generate a design, check its manufacturability, and give a near final quote to a client, all in the same environment.
That is a transformative level of control. Okay, lastly, let's talk about how the community sustains itself. It sounds very collaborative.
It's entirely collaborative. Designers can save their complex component clusters, their own custom recipes, as reusable snippets into the AlgoJewels Vault tab.
And the sources heavily encourage sharing these codes and ideas through their community groups.
Yeah, they frame it as a need a penny, take a penny, have a penny, leave a penny philosophy. If you develop a perfect bezel setting algorithm, you share it, and in return, you get access to hundreds of other advanced settings developed by other people.
It turns the solitary act of digital design into a collective, evolving environment.
That's it.
So what does this all mean for you, the listener?
Yeah.
The core takeaway is that AlgoJewels offers just this unprecedented level of control over complex jewelry forms. It lets the designer manipulate geometry through simple, traceable, market-aware inputs and sliders. It really bridges that historical gap between the artisan's hand and the engineer's calculation.
And with this structured, parametric approach, the designer is no longer limited by individual command clicks. Instead, you set up the rules, the algorithms, which can then explore infinite design possibilities while, at the same time, ensuring the final product meets every single functional and dimensional spec for a wearable piece of jewelry.
It's an incredible look at the convergence of math and beauty. And that brings us to our final provocative thought for you to chew on. Since all designs in this system start at that central origin point, 0, 0, 0, and rely entirely on universal geometry and vectors like angles and perpendicular lines, does something like AlgoJewels suggest that the most compelling, aesthetically pleasing jewelry designs aren't invented by human emotion, but are actually mathematically inherent structures, just waiting to be unlocked by the right algorithm?
Think about that reliance on universal math, on geometry like the dodecahedron, next time you see a beautiful jewel.
We'll see you next time.